Hi everybody. So we're continuing the 2021 Math MCAS. We're going to pick up where we left off. This is number 20. This is a digital copy of the test available in the video description as well as a printable PDF. So here we go. An airplane reaches an altitude of 9,000 meters and then begins to descend at a constant rate of 625 meters per minute. Which of the following equations can be used to determine y, the altitude of the airplane after x minutes? All right, so we're looking for an equation that represents the situation. So we're starting at 9,000, and we're decreasing our altitude by 625 meters per minute. So this would be our starting value, and this would be our rate of change. So let's look at this. We have a bunch of linear equations because it's a linear function, right? So we're starting at 9,000. That should be our y-intercept. So here we go right here. And it's remember, the rate of change is going to be negative 625 because we're descending by that much. So there you go. That's really it. This is just do you know a linear function essentially. So y equals mx plus b. B is the rate of change, also known as slope. And m is that. And then b is the, did I say b? I think I did. M is the rate of change, also known as the slope. And then b is the y-intercept, or starting value. So this problem's not too bad. You just have to understand what it's actually saying and how to describe it. Okay. Number 21. All right. The graphs of three functions, linear function f of x, quadratic function g of x, and exponential function h of x are shown in the coordinate plane. Select from the drop-down menus to correctly complete each sentence. And there's options here when you click it. Let me pause this and see what those options are. 1 second. Okay, so I just double-checked the options they have available. So each of these has basically all three of these functions. So we have the linear, which is f of x, the quadratic, which is g of x, and the exponential, which is h of x. So it's asking us, first of all, what is the greatest initial value? So the initial value is our starting value. So when x is 0, so the x value, the input is 0, what has the highest functional value? And that would be f of x. You can see this right here. That's the highest initial value. So that would be f of x then. Choose f of x, right? And then which function has the greatest value when x equals 50? So, all right, let's look here. So 10, 20, 30, 40, 50 would be up here. Okay, so this one's going off screen because clearly it is a good idea to ask people to interpret something off the grid, as MCAS is wanted to do. Okay, so you can see here that h of x overtakes g of x at this point, right around 27 for the x value. So the functional value of h of x surpasses that of g of x. So you can safely say that h of x will have a higher functional value when the input is 50. So the answer for the second part would be h of x. All right, so this is all about interpreting functions, all three, linear, quadratic, exponential. You really don't even need to really understand what's happening in the quadratic or exponential. You just need to understand that, hey, this darker line is ahead of this one, which means it's going to have a higher functional value. If you can do that, then you should be able to answer this second part. First part, you need to know what an initial value is. The starting value is here. You need to understand that this is a higher functional value. So, all right, let's move along. 22. Okay. Julio walked from one corner of a rectangular field to the opposite corner along a diagonal of the field. Okay, this dotted path must represent, the diagram represents the field and the path that Julio walked. Based on the dimensions in the diagram, what is the distance that Julio walked? So we're looking for this distance here. That's the diagonal. We want to know what that is. Okay. I think the easiest way to solve for this would be using Pythagorean theorem because it's a rectangle, which means this is a right triangle. So we have our A, our B, and our C. So we're going to say A squared plus B squared equals C squared. So 50 squared plus 120 squared equals C squared. So let's see, this would be 25 and 2 zeros. This would be 144 and 2 zeros. And this would be C squared. Let's add those together. We're going to get 16900. Equals c squared. We're going to do the square root of both sides. And the square root of 169 would be 13 times 13 times 10 times 10. So that should be 130 because it would be a 13 and a 10 on the outside. Let me check if the calculator is available for that problem. Let me pause it. Yeah, so the calculator is not available for this problem, so you'd have to be able to go from the square root of 16,900 to one of these numbers. So that's probably the part of the problem that people would get wrong. They'd have a hard time knowing how to simplify that. So let me show you how to do that a little easier than I did here. So 1,690. Sorry, no, I lied. 16,900 rather. So we can go 100 times 169, and then 10 and 10, and then 13 and 13. And you can stop there because this is a perfect square. It's a perfect square. And you go from there. You could keep going to 2 and 5s here if you wanted to, but it's just adding more work to you. So there you go. Let's start at number 23. Let me zoom out a little bit here. All right, number 23 rather. A worker at the Rainbow Garden Center planted multiple rows of flowers. There are 3 flowers in the first row. Each of the remaining rows has 4 more flowers than the previous row. Determine the number of flowers in rows 20 and 35, drag and drop, to correctly complete the statements. Okay, so this is an arithmetic sequence problem. Let's go ahead and write the arithmetic sequence formula here. So a sub 1 plus d, which is this is our starting value. D is a common difference. And then n is the desired term in the sequence, minus 1. So let me label that. So, right here. So first term, common difference, and desired term. I'm going to zoom in a little better so you can see that. Okay. All right, so we're going to use that. So our starting value is 3, which we have that here, so 3, plus the common difference, it's going up by 4, so it's a positive 4. And the desired term in this case will be 20. We'll do 20 first. So 20 minus 1. And let's do that. So 20 minus 1 is 19. So 3 plus 4 times 19. Let's do a little more here. 4 times 19 is going to be 76. Plus 3 is going to be 79. So 79 flowers for this one. And then the next one is going to be 3 flowers is our starting value, and then common difference is 4. But in this now, instead of 20, we're going to have 35 as our desired term. So 35 minus 1, so 3 plus 4 times 34. And then 4 times 34, let's do that over here. 34 times 4, 130, yeah, 136. Yep. This would be 3 plus 136, that'd be 139. And that's it. Okay, so let's say you don't remember the arithmetic sequence. Let's say you're doing this problem, and let's make 139 right here, and 79 right here. Well, you could do them all out. You could write these all out, like row 1 has 4. Sorry, row 1 has 3, right? Row 2 has 7, because it's going up by 4, then 11, then 15, then 19, and so forth and so on. And you could go all the way to row 20. It would just take some time, but you could totally solve this problem without this. This just makes it quicker. So again, if you forget this formula, if you don't remember how to do that, just write it all out. It's going to take you probably about a minute or 2, but you'll get the problem correctly. So both those methods work. It's number 23, by the way. Okay. All right, let's move along. 24. Let me check. I think is this the calculator section of the test? 24. I think we're officially in the calculator section. Or not. No, I guess we're not. Oh, no, we are. We are. Okay. I think number 22 onward is the calculator section, so that's good. You would have access to a calculator at this point. Okay. It's number 24. I believe this is the similarity problem. Yes, it is. Okay. So for those of you in my geometry class right now, we're learning about this. So in this diagram, triangle MNP is similar to triangle QRP. Okay. Based on the dimensions in the diagram, what is the length of QR? So we're looking for this distance right here. We're wondering what that is. Okay? So we're going to use our similarity statement. We're going to set up a proportion. So QR are the first two letters. That means they match up with MN. So we're going to say QR over MN is going to be equal to, and let's use let's use these two verticals. So QR is the smaller triangle. So that means we're going to go PQ or QP. All right, so this one. So those two are the blue. So QP over PM. Okay. So we'll do small over big. And now let's plug those in. So this would be our X. MN is going to be 4. QP is going to be 2. And PM is going to be 5. Okay. I'm surprised they didn't just give us this as like 3. And maybe have to calculate that, but it's kind of nice that they didn't do that. All right, so let's cross multiply and solve here. So we're going to get 5x equals 8. Divide by 5 is our coefficient. We're going to get 1 2/3, I believe. Yeah. Okay. So that would be, no, sorry, it's not repeating. I apologize. It's just one. It's 1 and 6/10. Yeah. There you go. There you go. Okay. Not too bad. As long as you know how to use a similarity statement, this problem should not be too tricky for us. All right, 25. Oh, here we go. Dimensional analysis problem. 25. A cup is in the shape of a right circular cone. The cup is filled with water to half its height, as shown. Based on the measurements shown, which of the following expressions represents the volume in cubic inches of the empty part of the cup? So if we're going to solve this, we're going to need the entire volume, and then from that volume, subtract the volume of the water, and that should give us the difference. That should give us the empty part. So we're going to need to know the volume of a cone formula, which is available to you in the exhibits button of the test. You just have to write that down. So I'm going to write that down here for you. It's just V equals 1/3 pi r squared h. So that's the formula for the volume of a cone. Okay, so let's find the volume of the big cone first. So 1/3 pi, what's the radius of the big cone? The radius of the big cone is 1.4 inches. So 1.4, and it looks like it's squared. And the height of the big cone is 2.1. Okay, so that's the volume of the big cone. And then we're going to subtract from that the volume of the small cone, which, okay, so 1/3 pi, and the radius is 0.7 inches, so 0.7, and that's squared. And then the height is 1.05. Okay, so that expression represents the volume of the empty part. It looks really crazy, but conceptually, you just have to remember it's the cone itself, that volume, and take out of that the volume of the water. That's what this represents. So this is the big, and this is the water. So if you take the water out of the big, it should give you the difference, which is the empty. And I believe, let me zoom out, I can slide over here. I believe that's just option B, I think. Let's double check. 1/3 pi, yep. 1.4 squared, 2.1, yep, subtract, yep. Yeah, that's it, it's just B. So you don't have to simplify, you don't have to actually simplify it, which is nice. You just have to know how to like identify it, okay? So most of you have not worked the volume of a cone yet. You will, hopefully, before you take the test. Well, you should. But this problem, as long as you understand how to find this part of it, like conceptually, okay, I just take this out of the whole thing and that'll be the difference, you should be fine, okay? But I can see why that problem would be confusing to some folks. All right, 26. A student graphed line segment PQ on a coordinate plane as shown. The student will plot point S on PQ such that the length of SQ is twice the length of SP. What will the coordinates of point S be? All right, so interesting. All right, so it's not a midpoint. I mean, you could find the midpoint twice. That's one way of doing this. And that's definitely one way you could do it, but that's not the way I would do it, to be honest. All right, let's read that again. The student will plot point S. We're going to put point S somewhere on PQ so that SQ, so from S to Q, it'll be twice the length of SP. All right, so we're going to basically be splitting this into thirds. We're going to have 2/3 will be from S to Q, and 1/3 will be from P to S, or S to P. Let's see what this rate of change is. Let's look at the vertical change and the horizontal change. I'm going to show you two different ways to solve this. All right, so I think this is the much easier way to do it, to be honest. All right, so the vertical change from -6 to +6, that should be 12. Let's just count to be safe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is, okay. So the vertical change is 12. And if they're both, I can't really read that here. If they're both divisible by 3, it's going to make our life a lot easier. -4 to 5, that should be a change of 9. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is. Okay, this is going to make our life much easier. All right, so let's split this into thirds. So 12 over 9, oopsie, 12 over 9. Let's simplify that. They're both divisible by 3. So 4/3. This line segment has a rate of change or slope of 4/3. Let's do that. So 1, 2, 3, 4, 1, 2, 3, okay? Let's do it again. 1, 2, 3, 4, 1, 2, 3. Okay, so now we have 3 congruent line segments. We have these 3 pieces. Now, S is going to be, so SQ is going to be twice the length of SP. So S is going to be either here or here. We want the distance to be double that of this. So this is obviously S right here. All right, this is twice the size of this right here. So if you can just understand rate of change, I think this problem is a hell of a lot easier. And the coordinates at this point are obviously -1, 2. Sorry, -1, -2. There's actually 3 ways you could solve this. So that's if you know rate of change. The other thing you could do is graph these and see where they are. Let's do that. So if you were to graph that point, you're going to see it's on the line and it is 2/3. Even if you don't understand the distance, like if you don't understand how the rate of change works, you could tell by looking at this is twice the size of that. But let's just plug the other ones in. So 0, -1/2. So 0, -1/2 is there. It's close. I could see somebody eyeballing that thinking it's 2/3. This is 2/3 of that, but I think it's far enough away where people would be able to tell that it's not. Then 1/2, 0. That looks like it's more almost halfway. I think that'd be easy to tell no. And then 2, 2, it'd be the other way around. It would say that this is 1/2 of this. So even if you don't know how to use rate of change, if you just plotted these points on the graph, you should be able to tell that it's not the proper proportion here. Also, if you wanted to do, no, actually that wouldn't work. That's probably the 2 best ways to do it. Yeah, but I think just, I don't know. I guess maybe plotting would be easier for some folks, but either way, that works pretty. I think it's a pretty doable problem. All right, let's look at number 27. I think we're going to make 27 a separate problem, a separate video because it's a 4-parter. I think I would like doing those as a separate video because they're a little more intense. All right, so that's going to do it for this video. Thanks, guys.